Hey, welcome. Ever find yourself staring at a right triangle problem, just feeling kind of stuck? Well, today we're building a simple, powerful toolkit that's going to help you find any missing side, no problem. Seriously, by the end of this, you'll know exactly what to do every single time.
Think of it like this. How do you find a missing puzzle piece? You don't just guess, right? You look at what you have, the shape of the gap, the colors on the pieces around it, and you find the one that fits perfectly. Finding a missing side in a triangle? It's the exact same idea.
See, solving these things isn't about some kind of magic or guesswork. It's about knowing which tool to pull out for the job. And the best part? Your toolkit only needs 2 tools. That's it, just 2. So here's our game plan for today. We're going to start by meeting our 2 main tools, then we'll walk through exactly how to use each one, put them to work with some examples, and then wrap it all up with a super simple cheat sheet so you never get stuck again. Let's get to it. Okay, let's dive right in. The entire secret, and I mean the entire secret, to getting these problems right is just knowing which of your 2 tools to grab based on what the problem gives you. It's a simple choice, and I'm about to make it crystal clear. Okay, listen up, because this slide right here is the whole game. Every single right triangle problem boils down to one simple question. What information do you have? If you know the lengths of 2 sides, you will always use the Pythagorean theorem. If you know one side and one angle, you will always use trig ratios. That's it. That is the entire decision, right there. All right, let's grab our first tool. This is for when you're given 2 sides. It's the Pythagorean theorem. You've probably seen this one before. It's a total classic for a reason. Yeah. A squared plus B squared equals C squared. So in a right triangle, you've got the 2 sides that make that perfect L shape. Those are your legs, A and B. And that longest side across from the right angle, that's the hypotenuse, or C. So the formula just says, if you square the 2 legs and add them up, you'll get the square of the hypotenuse. And using it is just 3 easy steps. First, square the 2 sides you're given. Second, you either add or subtract. Quick tip, you add to find the longest side, the hypotenuse, and you subtract if you're looking for one of the shorter legs. And finally, you just take the square root of your result. And that's your answer. All right, let's make this real with an example. So we've got a right triangle here. Its legs are 4 and 8. We need to find the hypotenuse, C. Now, what do we have? We have 2 sides, so we know exactly which tool to grab. Step 1, we just plug our numbers right into the formula. A is 4, B is 8. So we get 4 squared plus 8 squared equals C squared. Simple as that. Next, let's do the math. 4 squared is 16, 8 squared is 64. Add them together, and that tells us that 80 equals C squared. We're almost home. And for our last step, we just got to get C all by itself. So we take the square root of 80, and that gives us our answer. C is about 8.9. And just like that, the puzzle's solved. See? Not so bad. Okay, time to switch gears and grab our second tool. What happens when you don't have 2 sides to work with? What if instead you're given 1 side and 1 angle? For that, we need our good friends, the trigonometric ratios. And the key to unlocking these ratios is probably the most famous mnemonic in all of math, SOH-CAH-TOA. This little phrase is your absolute secret weapon. It tells you exactly which formula to use every single time. The process here is also just 3 steps. First, you stand at the angle you're given, and from that point of view, you label your 3 sides. The side opposite the angle, the side adjacent, or right next to the angle, and of course, the hypotenuse. Then SOH-CAH-TOA tells you which ratio to pick. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Once you've picked one, you just set up your equation and solve for x. Okay, let's jump into one. We've got a triangle with a 21-degree angle. The side that's opposite that angle is the one we're trying to find, x. And we know the hypotenuse is 22. So we have 1 angle and 1 side. We know it's SOH-CAH-TOA time. So let's break it down. From our 21-degree angle, x is the opposite, and 22 is the hypotenuse. Opposite, hypotenuse, that's OH, which means we use SO, or sine. So we write out our equation. Sine of 21 degrees equals x divided by 22. Now, to solve for x, all we have to do is multiply both sides by 22. Punch that into a calculator, and you find that x is approximately 7.9. And there you go. Our second tool just tackled a totally different kind of problem. Piece of cake. All right, you officially seen both tools in action, so now let's pick up the pace a little bit. We're going to do a quick practice problem to make sure this all feels like second nature, because it's all about recognizing the pattern.
Okay, look sharp. We've got a 55-degree angle. The side opposite it is x, that's what we're looking for. The side adjacent to it is 20.3. So the two sides we care about are the opposite and the adjacent. Which part of SOH-CAH-TOA does that sound like to you? That's it. Opposite and adjacent is OA. So we use TOA, which stands for tangent. We set up the equation tangent of 55 degrees equals x over 20.3, a little bit of algebra to solve for x, and we find our missing side is about 29.0. See? Once you know what to look for, it's a super straightforward process. So let's just boil this all down, shall we? You now have a complete system, a full toolkit for solving for any missing side of a right triangle. Let's put the whole thing onto one single ultimate cheat sheet.
And here it is, the whole shebang. This is the simple choice you make every single time you see one of these problems. Do you know two sides? Bam, Pythagorean theorem. Do you have one side and one angle? Easy, SOH-CAH-TOA. This right here is everything you need to remember.
You know, we've been focused on triangles on a page, but this is so much bigger than that. This is about understanding the relationships between distances and angles out in the real world. It's used everywhere, in construction, video game design, navigation, you name it. So the real question isn't about the next math problem. It's, now that you've got the tools, what puzzles out there in the world can you start to solve?